Yeah. Okay. My name is Emad Hamadi, and I'm here to discuss a crucial topic that affects the safety and the efficiency of the industrial operation, and that's arc flash study. All right. Today we will explore the importance of conducting the comprehensive arc flash study. We'll discuss how this study can enhance the workplace safety and protect the valuable assets and ultimately provide a significant technical and financial benefit to your operation. Hopefully, by the end of this presentation, you will have a clear picture of how this study will be performed and how it may benefit your industrial environment. Uh, as you know, the arc flash is unpredicted discharge of the electrical energy, which can result in serious injury and even fatalities for workers exposed to the arc. Several potential causes could trigger an arc flash that I listed here, and I don't want to go into the detail too much because I'm quite sure that you already have a very solid understanding of the basic knowledge and are familiar with the cause and the effect of the arc flash. I think also David and Jason has well covered this part. But anyway, I mean, this slide I just put two of the causes. Let me just turn on my laser. Which one of them, which is tend to be less likely to happen, I would say, and this is ionization of the air, which, as you can see, it's happening phase to the phase. This one is the compartment of the STG steam turbine generator, HV1, and it's quite a clean compartment, but this happened due to ionization. And that one is the insulation deterioration that causes the arc flash. And that was, the status in the early stages. Actually, I mean, this was the other end of this cable. That, as you can see, is the build-up heating into the termination of the cable. That could probably be avoided by intrusive maintenance, or, as Jason mentioned, by the PD monitoring. Um, but again, I mean, this is the consequences of the arc flash study, arc flash itself, which David gone through that, all of them, possibly, and then I'm not going to just repeat them, but as everybody knows, it has the human impact and financial and equipment impact as a result of the arc flash. Now let's focus on the main subject of the presentation and talk about the aims and objective of arc flash study. Why would we need an arc flash study and what it give us? Um, in my experience in the design field in the UK, I've seen that the arc flash study, unfortunately, was often considered as a fancy piece of information or a good to have at its best. However, this perspective, I think, that been changed in the recent year, which is a good news. The arc flash study is essential for several key reasons, which guide us in mitigating the arc flash risk in general. Which here I'm trying just to mention five main reasons of that. Mm, First, the study aim is to evaluate the potential severity of the arc flash incident in different parts of the network. This could involve calculating the prospective heat energy released by an arcing fault in various locations. And by doing that, we can identify the weak points of the electrical network and understand the severity of the risk in different sections, which could be crucial for the company's HSE department, for example, as it allows them to conduct a more accurate risk assessment and enabling them to implement the target measures to enhance the safety and reduce the risk, or choosing the right PP and so on. The other one, which is one of the critical objects of the arc flash study, is to determine the safe working distance from the energized electrical switchgear or the equipment in general, which is crucial for ensuring the safety of the personnel who operate near or on the energized components. As you know, it's very typical for the operation or the maintenance team to undertake the routine daily check near the equipment. Or in many sites, I've seen, personnel override, the panel lock to open the compartment when it's live for various reasons, such as testing or fault finding, or as Jason mentioned, in the low voltage, it's very typical to do thermography. So the thermography need to be done under the live conditions, so it's inevitable to open the compartment and get access to that. And this could happen, actually. It's happened in one of our sites that we worked in. As you can see, it's a very small compartment. And it was the same scenario. The electrician overrode the lock and access to the compartment. And this happened. And unfortunately, it led to the burn on the hands and the eye injuries, which could easily be avoided by the proper PPE or maintaining a safe distance. So, I mean, the safe distance is crucial, and I've seen in many sites, they marking, the floor with the arc flash boundary, which is a very good practice. For example, in one of the projects that we were designing the electrical network, the client asked to conduct the arc flash study in the early stage of the project. And based on the arc flash boundary and the safe working distance, they design the equipment layout and the civil of the enclosure, marking up the floor and walking path, which was a very good good practice, I would say. Okay. One of the key objectives of the arc flash is to propose a solution, an option for reducing the potential hazard associated with the arc. This is, in fact, identifying and implementing different strategy to mitigate this risk in a cost optimum way, if you like. For example, the fine-tuning protection settings. I saw a question, asked from David regarding the arc flash or the protection setting and how the protection setting can, or if the protection setting can reduce the arc flash. Yes, it can be done. Actually, it is one of the way of reducing the arc flash. But don't forget, the protection settings, they have other priorities as well. I mean, the protection grading study is done in a way to mitigate the risk, yes, but it also to minimize the system disruption. And normally the grading of the protection setting is in a way that it's wait for the closest relay to the incident to trip first, and it has time delay. I mean, you can just set all the settings in the network to the instantaneous tripping and put it in the lowest settings, and you have a safe side from the arc flash perspective. But then you end up with a system that is very vulnerable to or very sensitive to the fault, and any fault in the downstream can lead to the blackout. So the protection setting, yes, it's a way of doing that, but it just gives you limited room to maneuver, if you like. And if you want to go further, you need to just use other measures like the arc flash detection system, which they are operating independent of the protection system and can trigger, in case of the arc flash. So the proposing and developing, the solution for reducing arc flash hazard is one of the outcome of the arc flash study. Just put, some case study here that, I mean, the site request to assess, the arc flash or do the arc flash study, and we identify, different location with a high energy level. And then we propose, a few measures. One of them was, just to fine tuning the setting, the protection setting, which overcome, I mean, the issue and reduce, in some locations. And for those locations that it was not possible, to reducing the incident energy by the arcs, by the relays, we installed the arc flash relays, and we end up with a system which is safe and sound in that perspective. Yeah, another outcome of the arc flash study is just to determine the PPE. I mean, choosing the right PPE is very crucial in the industry. I use that most of the time. I see sometimes if you don't know what type of the PPE wearing to wear for the switching, I mean, if you don't wear anything is probably safer. So choosing, the right PPE is crucial in the industry, and you need to know that what type and what kind of the PPE you need to wear for the switching, or if you're operating near the electrical equipment. And finally, the overreaching goal is just to provide a reasonably practical, safe work environment by implementing the effective measures based on the study finding to create a safer work environment for everyone involved. The objectives collectively contribute to the comprehensive approach to managing and mitigating the risk associated with the arc flash in the work environment. Okay, the next subject is the standards. Actually, when we're conducting the arc flash study, it's crucial to adhere to the established standards. Here are the key standards that we are using for the calculation. First of them is the IEEE 1584, which I think the latest revision is in 2018. The previous revision was in 2002. And the updated one has a great update. So this is standard particularly valuable for the detailed guide on modeling and calculating the potential arc flash hazards. And the next one that I think has been mentioned with the other colleagues is the NFPA, which is the latest revision released in 2024, titled as Electrical Safety in the Workplace. These standards provide essential safety practice designed to protect the workers from the hazard, the electrical hazard, including the arc flash. And NFPA is focusing on the practical safety measures and the procedure, making it crucial for the reference. There are a few other standards in this field, which like DGUV 2003, which is I think the standard used in Germany, or another standards in IEC, which is 60947, which is details the which is dealing with the arc flash mitigation system. Or the other standards that are focusing on the specific aspect of the arc flash, like a PPE or the other aspect of the arc flash. But these standards are typically used for the calculation of the arc flash study. Next topic actually is talking about the analysis process and what we're doing actually, how this process is performed. In short, the arc flash study got some input, which is the system and installation data, and control and operational mode, and the arc flash study itself, which is the calculation, and the outcome is the incident energy, the arc flash boundary, and the required PPE in different part of your electrical network and the system. The process is normally done in 11 steps. These steps are based on the IEEE 1584, which we start with processing gathering the critical data that form the backbone of the analysis and enabling us to understand the dynamic of the electrical system. Following this, we use the precise calculation to determine the energy level associated with the arc flash incident and the safe boundary within which the personnel can operate. Going through the slide one by one, the first one, which is, I think, is the most significant effort in the performing our flash hazard, is collecting the data of the electrical system. This step is crucial, even if the facility already have up-to-date documents like single line diagram, protection study, and the short circuit models on the computer. And normally take about half the effort, the total effort and the cost of the study, I would say. This is why the cost of the arc flash can vary from site to site, mainly due to the extent of the existing documentation and the condition of the facilities. Sometimes we see sites that lack of basic documentation like single line diagram. This deficiency require additional manpower and the time to inspect the site and extract the necessary data and the potential and potentially schedule the power outage to access to the panels. All these factors contributed to the time and the cost involved with that. Even for new facilities, field verification of the single line diagram with the protection settings is necessary to ensure the integrity. In general, the data required for an arc flash study is extensive, and the key elements like the single line diagram, the fault current, X/R ratio for the sources, nameplate data from the transformer, generator, large motors, and etc. Is required, or additional information like the enclosure size, the electrode configuration, cable data, CT and VTs, and the protection devices is also critical. And as I said, the field inspection may be necessary to verify the all of these, the fuse type, the circuits, breaker settings, protection relay settings, and etc. The more accurate or the more thoroughly collecting and verifying this data, you can end up with a more accurate and reliable arc flash study. This is just an example of the site. That is a very small project that we work on that, but due to unavailability of the sufficient data, we had to spend a lot of amount of time to extracting the necessary information and creating the single line diagram. So sometimes, despite the project, a small scale, the lack of existing document means that the team had to conduct extensive, data collecting and, producing, the single line diagram and just putting all the data in the elements on the network is a time-consuming task in general. The next step is also crucial, is determine the system mode of operation. A very important step is to understanding the different mode of the operation, the electrical system. Each mode can significantly impact the short circuit, which is in turn, affect, the incident energy calculation. To determine the system mode of operation, we must identify the scenarios that provide both the maximum and the minimum available short circuit, which is require a thorough understanding of the control philosophy and the possible, switching sequence. In complex systems, there are many modes of the operation that all need to be considered. Okay, I think I lost a bit the track of the time, so going through that. This is just an example of the project that we work on that, which during this assessment of the operational scenario, we find out some network configuration that could practically lead to a fault level exceeding the switching rating. And so, this is the highlighting, the importance of considering every possible mode of the operation. And so that's the point is, you unless you conduct this study, you would never know about such issues. And our flash study provide the valuable insight into your system that how it can behave in the case of fault. Okay, well, one more thing while we are on this slide, I just want to mention is that I come across in many, sites in the UK, especially in waste to energy power plant, which they are normally, connecting the steam turbine or turbine, directly to the main bus bar, like 11 kV bus bar. This is okay in general from design perspective, but it will result in high asymmetric fault currents, which have a high decaying DC component, which cause the risk of the circuit breaker opening in non-zero, current and potentially damaging the circuit breaker, especially if it's not capable of handling that amount of DC components. I've seen in sites which normally what they doing, the designer, they putting some time delay in the instantaneous over current relay to allow for the DC component to decay, so that the current can pass through its first zero crossing. I mean, this delay, although it's just for a few cycles, it could considerably increase the incident energy. And for example, in this project, we had this issue and we had to install excessive arc flash relays on the main bus bar to mitigate the issue. And so, I mean, this is, the main bus bar that we have, and you can see, I mean, so many relays over there just because of that issue that we had. So just back, to the question of our colleague regarding the protection settings. Sometimes you cannot reduce that because, I mean, you make something else worse. So protection study and arc flash relays is two of the main measures that you can use to end up with a low incident energy throughout your network. The next step is determine the voltage fault current. Actually, it's very important, to just run a thorough short circuit study. And if the short circuit study is not available, it will be necessary to perform one as a part of the arc flash study. And you need to just consider everything, the motors, the generators, everything that could potentially contribute into the point of the fault in terms of the short circuit, need to put into the account. And you can find out, the short circuit everywhere in the network, all pieces. And based on that, you run your arc flash study. And it is important to also, find out the higher and the lower short circuit, because the lower fault current may result in longer opening time for the overcurrent protection devices, therefore increasing the incident energy in general. This is just an example that we find the incident energy level was considerably higher when the system was connected to the emergency diesel generator. So this is the system, it's connected to the DNO, to the grid, national grid, and this is when the system is connected to the diesel generator, emergency diesel generator. As you can see, there are the same points, and when it's connected to the diesel generator, the energy level is very high. Although the fault, if you can notice that, is lower compared to when it's connected to the national grid, but because of the clearing time, tripping time, the level energy is very high. This situation particularly concerning because the emergency diesel generator are typically in service during the power outage or critical situation, which are also the time for the personnel that are more likely to investigating the issue and working close to the panels. Therefore, the risk of the exposing to the high incident energy level is greater during this situation. I've seen in some sites, they doing the arc flash study only for the main source of the power, and they omit, the other source like diesel generator, just assuming that the higher fault level will end up with a higher level energy, which we know that it's not true all the time. The other next steps actually are like determining, the typical gap between the conductor equipment or the electrode configuration and the working distance. They are available in IEEE 1584, which is provide typical values via specific tables, which can be used if this some of this data can be obtained from the manufacturer, but if they are not available, then you can just refer to these standards and the tables and get some approximate data, which is quite accurate actually. And you can refer that and have a good approximation guide at the end. So up to here, it was analysis, it was, the data collection, and the other steps are associated with the calculation, the actual calculation, like the arc current, which is the function of the voltage fault current. And there are certain equation in standard for calculating in different fault condition. This is just one example of that equation. Or the arc duration, which is the critical factor in determining the severity of the arc flash incident. And it's defined as a time that it takes for the upstream energized source to stop providing current to the arc fault, which depend on the protection devices and the time for the circuit breaker to open, or time for the signal traveling, any intermediate relay or lockout, and also the time for it takes for the stored energy to be discharged through the arc flash. So this is, time of the clearing time, actually, or defined as a clearing time. And also, when we're doing this calculation, it's important to recognize the multiple arcing location, which can exist in a single piece of equipment. For example, in a single circuit breaker compartment, the incident energy before the circuit breaker, before the contact for the incomer and outgoing, can vary significantly. Therefore, the incident energy need to be calculated for the worst case scenario, and you can ensure that that you just account for the worst case, and you just design your arc flash label at the end of the day based on the worst case scenario. The other step is the arc flash boundary, that is defined as a distance that the potential arc flash will reach the incident energy of 1.2 calories per square centimeters. Why this is a specific important? Because 1.2 calorie per centimeters is just considered as a safe distance, or have a minor effect or consequences, and the people can actually can walk through that without any specific PPE or very low level PPE, let's say. And the arc flash boundary is one that you can just mark it up when the staff are working on the live panel. And the final step is just selecting the right PPE, as I mentioned, earlier on, which is these critical measures, like category 1, 2, 3, 4, are based on NFPA, actually, the guidance of the NFPA. But eventually, the type of the PPE need to be decided by the duty holder or HSE department of the company, to just, and these are used as a guide, basically. In short, all the outcome of the arc flash study can be summarized into the final arc flash label that can be affixed to the equipment and are essential for informing the staff about the potential hazard and ensuring the safety compliance. I mean, the arc flash is coming in different design, but at the minimum, it should contain the incident energy, the PPE requirements, arc flash boundary, and need to be has like a shock hazard levels, equipment identification, and the dates of that. I need to be placed it on any piece of electrical equipment that could potentially pose an arc flash risk. Some additional information can be customized as per the client preference. I had a discussion with my colleague the other day who believed that a relevant protection setting and the study and the document that based on those documents, the arc flash has been conducted, and this is the outcome of that, need to be listed here. So yeah, any of these input data, if they change, I mean, all these lose validity, and you need to just revalidate, the arc flash studies. Yeah, and eventually you can, just fix all the labels with your customized design to the equipment. So let's talk about the software. It is obvious that nowadays nobody uses the hand calculation because I mean there are very accurate software available in the market that can be used for the arc flash study. Normally the softwares are designed to support compliance with different standards like IEEE, NFPA, or etc. And one of the key strengths in the software is that they are comprehensive, and they do, a full, thorough analysis capability and provide the detailed incident energy analysis. They also simplified, the process of calculation and have different label design and make it easy to generate a professional quality reports and the arc flash hazard label. Yeah, I mean, in summary, software is an essential tool that helps to end up with very accurate, arc flash studies. This is another case study, actually. I mean, this happened in one of the sites. The arc flash happened. Following the incident, the management was advised to install an extensive, arc flash protection and partial discharge system. However, they decide to conduct an arc flash study first to better understanding. The study reveals that only specific area has the are sensitive or vulnerable to the arc flash hazards, and we managed to just reduce that with a very cost-efficient approach by changing the setting and eventually installing only 2 arc flash relay, and we end up with a safe and sound system at the end of the day. Yeah, so this is almost all about the arc flash, not all about, but the arc flash study.